Java 9 modules. In this section we'll learn about Java modules. We'll also have a Java 9 module example, and finally we'll have a look at multi-release jars. Introduction to Java modules. In this video we'll learn about the Java 9 Platform Module System, or JPMS. We'll learn why Java needs modules, we'll learn what a module is, and finally we'll have a look at the module-java.class descriptor and its associated syntax. Why Java needs a module system. There are a number of reasons why Java needs a module system. These include Java getting too big. For example, the runtime.jar file rt.jar is too big for a lot of Internet of Things devices. Pre-Java 9 also had poor internal encapsulation in jars, so basically if it's on the class path and has a public method we can access it, which means we can also access internal APIs, for instance the security APIs. Finally, the module system is designed to encourage loose coupling between modules and emphasize single responsibility, so one module should focus on doing one thing well. What is a module? A module is a collection of code and resources, or more succinctly, a module equals code plus resources plus the module descriptor, which is module-info.class. Or we can think of it as a jar file with a module-info descriptor. The module places itself above packages in the Java hierarchy. This means the module descriptor can control visibility of the code within a package or a jar file. So access to public methods and classes in a package can be restricted by package. Defining a module. The rules on defining a module are that it requires a unique name, where we stick to the reverse domain naming approach that we use for packages in Java. Although it's worth noting that a module name isn't a package name. We can only have one module-info class file per module with no submodules, and finally a module can contain any number of packages classes. Module path. The module path is the module version of the class path. It contains a list of module jars or expanded directories to allow non-JDK modules to be located. All artifacts in the module path are turned into modules with two special modules, the automatic module, which is a jar file without a module-info.class. The module name here comes from the manifest file, where there's a field automatic-module-name, and if that doesn't exist, then you would just use the file name of the jar file. And then we have the unnamed module, which is all the other jars and classes on the class. Module-info.class. Let's work through the syntax. In this example, we have the module-info.class is at the project root, and we have module com.javabullets, where com.javabullets is our module name. This isn't a package name, it's the module name, and it has to be unique within our application. And then we have two aspects of syntax. So we have requires, where what we're saying is com.javabullets.module1. This is a dependency that on another module, so in our system we would need to provide module 1 for our module. And then what we've got is com.javabullets.open. This is the package from within our module that will be visible externally. There are two additional versions of requires. One is requires transitive, where any module that depends on your module will automatically depend on the module that requires transitive. And then we have exports package to module, where we can restrict further who has access to the underlying package. So if we've got, for instance, we could have exports com.javabullets.open to com.javabullets.module2, and anyone apart from, and only module 2 would be able to see the package that we've exported here. Module-info.class additional syntax. There are other additional syntax relevant to the module-info.class. These are uses class name, where the current module is a consumer for a service, that is, the object implements an interface or extends an abstract class. Then we've got provides class name with class name implementation. This registers a class implementation as an implementation of the class name. This means that the module can provide its own service implementation. Then we have opens package name, and this deals with reflection. That's something that's been missing from the discussion so far. But packages can also deal with, modules can also expose packages for reflection. So in this case, if we use opens, you would have access to package name, and then we've got opens package name to module name, which is a restriction on reflection to a specific module. By using opens, you're breaking encapsulation, as even private members can be accessed. It's also worth noting that opens provides runtime access to private methods. There are a number of command line options available for Java modules. So we have Java, so we would have -module-path, which specifies the module path. We've already seen this when we've been working with JShell for HTTP2 client. Then we have -list-modules, which displays the names and versions of modules. Then we have -patch-module, which adds or overrides classes in a module. Then we've got add modules, which will add modules to the default set, and add exports, which allows you to add additional exports to your module, or add reads, which allows you to add further versions of requires, and finally add opens, which allows you to expose packages from the command line for reflection. In this video, we've introduced Java 9 modules.